Hi, I'm Randi Altman with postPerspective, and it is NAB time, and very excited about the show. postPerspective has a ton of stuff going on. We'll be at our booth each morning, recording interviews with people that make equipment and people that use the equipment. We'll be roaming around, figuring out what is the coolest new tech. We're going to talk to Doug Roble from Digital Domain, who is speaking on a panel at the show about AI and machine learning. So Doug, why don't you dig in, let us know a little bit about what the panel is going to be covering and give us some expertise on machine learning and AI.
Absolutely, and thank you for having me here. This is fun. So on Monday, I think actually at 3:30, I'm going to be part of a panel, and it's a part of a series of panels about how artificial intelligence, machine learning, all sorts of things are changing the industry, right? And so Rick Champagne from NVIDIA is sort of setting this program up along with a bunch of other people. And their thesis here is that, well, certain companies are trying to really push things forward. And so he's got a bunch of people on this panel from all sorts of different aspects of our industry that are going to talk about how they're using machine learning to sort of change the way that we're doing things and how it's really sort of shaken our system up. And so it's going to be fun. It's going to be a lot of, it's going to be interesting. And I'm going to talk about specifically, we've been using machine learning for a couple of years now. You know, we did Thanos in the Avengers last year. And a lot of the facial motion in Thanos's face was done with a variety of machine learning techniques. Since then, we have taken that technology and really tried to push it harder. We've tried to take the machine learning aspect of it and put it on a real-time digital human. So what that means is I've actually got a digital copy of myself. It's very realistic looking because of the latest graphics cards and stuff. And then the control of my character is real time in that it can look at my face and translate the expression on my face onto this digital character in real time. And it's unbelievably cool. It's very neat. It's kind of like, oh my gosh, digital humans are actually going to be starting to be in the, you know, vernacular. This is going to be a thing. And there's lots of uses for this, but obviously for visual effects, for previs, for virtual production, having a character that an actor can control super easily because there's no dots, there's no nothing. It's just a single camera looking at my face. All of a sudden, I can create and control this character. So this is really exciting. And this is what we're going to be talking about, and kind of like how it was done, what the differences are in how you work with machine learning versus how you work with just normal software and engineering. And yeah, it'll be fun.
So how much time will this save for a studio like yours, and then in turn money?
That's an awesome question, and it's not necessarily an easy question to answer. For instance, what we're trying to you know, with the stuff that we've looked at, machine learning is a different way to approach a problem. Like if you want to use, we've been playing around with using machine learning for doing something like fluid simulation, right? To do fluid simulation for visual effects. And if I know that I'm going to do 50 shots of a specific kind of an effect, using machine learning can give you a really big leg up there. But it takes a certain amount of preparation. In that machine learning is not just this magic bullet. What you have to do is first build a system that understands how fluid moves, or at least can be taught to understand how fluid moves. Then you have to capture the data of the fluid moving. So you already have to have a fluid simulator that you're happy with. You have to have something that can generate a whole bunch of, you know, water in a bay where two robots are fighting. Well, we have to have something that can create that data that we're going to be using to train the machine learning system. So if you're just going to do a one-off shot, machine learning is probably not the way to go. But if you're going to do 50 shots or 100 shots or a whole series of something where these shots are going to be coming up over and over again, then you take the time to simulate a whole bunch of, generic shots, enough so that you can train a machine learning system, which is not cheap either. It takes a long time to actually build one of these machine learning things. But at the end of it, you get something where you can do fluid simulations in real time. Once the computer understands how water moves, it can run staggeringly fast. And so you've built this thing that then can just do the kind of shots that you want it to do. And that's what we're doing with faces. With faces, we're doing digital humans, and we're learning everything about a certain actor's face, in this case, my face. And we're spending a lot of time figuring out all the details and measuring my face and watching how it moves and changes. And then we take that understanding of my face and use it to train a machine learning system, a deep learning system, so that when it sees an image of my face, it knows exactly what's going on with my face. So this takes time. This is not trivial. But once you've built it, we have something that can run at 60 frames a second and turn my face, my real face, into any character you want. So cool. So it is not a magic bullet by any means, although there are some aspects of machine learning like noise reduction and rotoscoping and stuff like that, where once they're built, it's just going to change the industry, and it already is starting to change the industry. But then there are other aspects of machine learning where it's like, okay, we've got to build it, and then we can use it. But that building it is not trivial. That makes sense?
Absolutely. And you said that Digital Domain has been using machine learning for a couple of years now. How have you seen the technology grow or change or adapt in that amount of time?
Oh, that is an awesome question as well, because, oh my gosh, is it changing? Machine learning really started becoming part of the dialogue about 10 years ago. And this was mostly at companies like Google and Facebook, where they had a lot of resources and a lot of data that they could work with. Over the last 5 years, though, machine learning has gotten the software and the foundational stuff of machine learning that these large companies have produced and other researchers and universities across the world have produced. It's gotten out there. It's over, and there's a ton of open source software out there that you can just download and use it to build your specific thing on. So over the last 5 years, this software has gotten really good, really easy to use, as long as you kind of understand the concepts. And also the computers have gotten really fast. This is the panel we're going to be talking about is headed up by Rick Champagne from NVIDIA, and there's a reason for that. NVIDIA's graphics cards are super important for all this. They run the machine learning really, really fast, and you need those things in order to accomplish the kind of stuff that you want it to accomplish. So better software, better hardware, and a better understanding of how to use this in our application areas are the things that have changed over the last 5 years that make this now a way of dealing with problems that we used to deal with. And I will say that the amazing thing about this is it's a totally different way of looking at problems, right? Over the last 20 years, whenever we wanted to do a problem, like say simulating muscles or something like that, we would get into the physics of everything, get into it, and then we get the mathematics of the physics, and we start thinking about how the muscles deform and move and preserve volume, and then we'd have to model it and use finite element techniques and all sorts of mathematical tricks in order to get this thing to work. Now, if we want to simulate muscles, a totally different way of looking at the problem is to go and say, well, maybe if I just get a couple of people in and I watch how their muscles move, and I actually measure how their muscles move, and I do this enough, I can generate enough data so they can train a system that will automatically figure out how muscles move. And so it's this different thing of like, here we analyze and we come up with the mathematics and do all this kind of stuff. And then over here, we just say, can I create enough data so that the machine will figure out how it works? and it turns everything on its head. It's so interesting to think about. And gathering that data is often quite tricky. You know, big data sets are really valuable nowadays. And when that kind of stuff works, you can make leaps and bounds over what we were kind of whittling at over the 20 years or so in computer graphics.
Well, Doug, thank you so much for giving us a little glimpse at what you're going to be talking about at NAB. Really appreciate it. Look forward to seeing you in just over a week. And I wanted to.
Yeah, right.
It's crazy. It's coming quick. So to everybody out there, come visit postPerspective at SL 8730. Say hello. Also, get your passes if you haven't signed up yet. Sign up soon. We'll see you next time.